Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to continue looking at the probability distribution and the mean of the probability distribution. So I want to take a look at something that might be a little bit surprising, and that is the mean. The mean. And we found out in our last video how to calculate it, and I want to pick up here with a little bit more clarity and then an application. The clarity is this. I wrote this as the mean equals. Now, when you're talking about having 4 children, we wrote the whole world of possibilities. This wasn't a sample, no. This was the actual thing, the actual situations that could happen. So because of that, this isn't mean as in a sample mean like x bar. This is the mean as in mu, all possible mean. We're taking a look at the population of outcomes. Okay, so when you're talking about a probability distribution, we're referring to the mean as mu. Now, I want to give us an example. Let's take a look at an example of when we might use the mean for a data set. So here's what we're going to do. Let's try this. How about this? A bond. We're going to probably try 2. A bond pays, how about 6% annual interest. Let me fix some of my word inter. 6% annual interest. Invest $10,000. I know that's a lot of money, but let's just imagine that we had it and we wanted to invest it. And if you could get 6% annual interest at the time of this recording, it would be worth considering. Now, there's always a problem whenever you make an investment, and that is your investment might not pay off. So let's do this. How about this? The default, F-D-F-A-U, the default rate of such bonds is 2%. Find the expected value. Find the expected value of the bond. Okay, let's try that. So I just put in an entirely new word, one that you don't know yet, and I need to clarify that. And that was this, expected value. Here's what expected value is. And not only that, expected value and we usually write it as E of x equals, all it equals is mu for probability distribution, when, this is the funny part almost, when money is concerned, when dollars, I shouldn't say dollars because you might be in a place where you use a different kind of currency, when money is concerned. Wow. So in other words, you know how to find expected value. Let me show you how we set up the probability distribution. Okay, here's what we're going to do. So I'm going to set this up. Let's think about this. So x, when we do these, when we construct a probability distribution, we usually write this as x as our net gain. our net gain. So we're going to have to think Now, in terms of nets, all right, we can do that. Now, if you hold the bond for a year, at the end of the year, you receive interest. So that would be good. You'd have interest. Now, what else could happen? Well, if you get interest, your net gain is the interest payment. Well, the interest payment is the $10,000 times the annual interest, which is 0.06. That's how much the bond would pay you at the end of the year. Now, there is always a risk in making an investment, whether it's stocks or bonds or real estate, and that is default. Sometimes companies make bonds and then they can't pay them. Well, there is a chance. If this bond defaults, what's your net gain? Your net gain is minus $10,000. You lose everything. Okay, so that would be our probability distribution. So now what we want to do is the probability of these. Okay, well, the first one we know is the default rate. The default rate is 0.02. So there's a 2 out of 100 chance that bond goes, that company paying that bond or the government paying that bond goes under. Well, what else could happen? Well, there's a 1 minus that, 1 minus 0.02, that's 0.98 chance, 98 out of 100, that the bond will pay. And that's what we hope for. So what do we do from here? Well, look at what we have. This is just our X1 interest. Default is the other event, X2. And we have the probability of X, so we can calculate the expected value. So the expected value on this bond is the X, which is 10,000 times 0.06, the interest rate, times its probability of 0.98 minus 10,000 times the default rate of 0.02. So this, let me see, I'm going to have to grab a calculator here. Hopefully you don't mind. So let me grab a calculator here. There's one. How about this one? Okay, let's try this. So let's put these numbers in. So we have 10,000 times 6.06 times its probability of 0.98. Subtract from that the 10,000 times the default rate, or the probability of default, 0.02. Enter, and we have 388. 388. So, and these are in dollars, and I should write this dollars. $388. Now, this is kind of a strange number, and let me explain why. The interest, if the bond does not default, then you would expect your interest payment to be the 10,000 times the 6%, which is $600 coming to you. Okay, but what does this 388 mean? This means that if you were to hold a portfolio of bonds, like a mutual fund of bonds, and you had a whole pile of these things, maybe you had 100 of those bonds, you would expect 2 of those bonds to default, and you would expect 98 of those to pay. Well, if that's what happened, each bond of your total 100, when you figured out your profit, at the end of the day, you would have made an average of $388 over your entire portfolio of bonds. So the interesting part about expected value is, do you get to see whether there's a profit or a loss make to the investment. However, what is more difficult is that expected value is a long haul average. Like if you were to run 100 of these, or 1,000, or 10,000 of these. So that's the basic setup. In our next video, we're going to take a look at an insurance company and expected value. I hope this helps, and thanks for watching.